Imagine an orchestra playing a cosmic symphony, an immeasurable number of stars, planets, and moons all playing in perfect harmony. However, there is a specific section of this orchestra that has perplexed astronomers for centuries: exoplanets. Exoplanets are more than just planets, they are worlds outside our solar system, hidden deep in the Milky Way. You may be surprised to find out that among the vast number of cosmic objects, there's an exoplanet so similar to Earth, so tantalizingly similar yet enigmatic, that it could be our planet's celestial twin. We delve into the fascinating realm of Proxima B, located just 4.2 light-years away. The James Webb Space Telescope is changing the way we search for and understand these celestial enigmas. Imagine a time when your thoughts travel across the vast expanse of our galaxy, the Milky Way, home to more than a quadrillion exoplanets. That's a 1 with 15 zeros. To put this number in perspective, if each of these exoplanets were the size of a grain of sand, we would not only fill the Grand Canyon, but we would have enough to create a new geological monument on Earth, a Grand Canyon 2.0 that would stretch for miles. What is most astonishing is the fact that about 20% of these celestial bodies have been classified as Earth-like, in terms of geological structure and atmosphere, indicating there is a 1 in 5 chance of finding a true twin of our planet. And the story doesn't end there. Along with these planets, there could be another quadrillion moons, rocky satellites, similar to our moon, locked in gravitational dances with their parent planets. If you were to bet on the possibility of discovering another body in space that harbors life, or could do so, the universe offers an abundance of opportunities. Now that we have unfolded the canvas of cosmic scale, it's time to introduce the master artist equipped to paint its intricate details, the James Webb Space Telescope. This celestial Sherlock Holmes, with its magnifying glass replaced by a telescopic lens, outperforms even the most advanced smartphones. We are not talking about just any optics here. Its 6.5-meter primary mirror is 2.7 times larger than Hubble's. Imagine the finesse. It can pick up even the smallest flicker of a star billions of light-years away, and then examine the specifics of orbiting planets. What makes the James Webb Telescope revolutionary is not only its observing power but also its advanced technology, including infrared sensors and spectrographs. These tools can do much more than observe. They can analyze and filter the unique light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, composition, density, and even mass. Acting as a space forensic scientist, it can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these questions, elevating it from a mere observer to an analytical genius. It's not just an advancement over its predecessor, Hubble, it's more like a quantum leap. If Hubble's discovery surprised you, get ready for a vertical feast of celestial revelation. Just as we've broadened our gaze across the complex landscape of the cosmos, it's worth focusing on one particular star in the celestial show, Proxima B. Since its discovery in 2016, this enigmatic planet has stood out as a Shakespearean protagonist, full of complexity and paradoxes, captivating astronomers and astrobiologists alike. What's all the fuss about? For starters, Proxima B is practically in our cosmic neighborhood, just 4.2 light-years from Earth. To put it in perspective, if you could beat the universal speed limit and travel at the speed of light, you'd get there in just over 4 years, about the same amount of time it takes for your favorite TV show to be considered mediocre or for a presidential term to conclude. But let's dig deeper into why this proximity is so important. We're talking about a universe that stretches over 93 billion light-years from end to end, so finding a planet so close and so promising for scientific research is like finding a diamond in a pile the size of Mount Everest, a diamond that potentially holds secrets about life itself. In the grand tapestry of the universe, Proxima B is an intricate stitch, providing us with crucial clues that could redefine our understanding of habitability and life beyond Earth. It's not only the close proximity of Proxima B to Earth that excites the scientific community, but also the tantalizing clues that this planet is not only Earth-like but possibly Earth 2.0. Proxima B sits comfortably in what astronomers call the habitable zone, or Goldilocks zone, of its parent star, where conditions are neither too hot nor too cold but just right for liquid water to exist. Imagine waterfalls, meandering rivers, vast lakes, and perhaps even oceans as deep and mysterious as the Mariana Trench. But before we start imagining a vacation on Proxima B, let's consider some of its peculiarities. For starters, a single day on this intriguing exoplanet lasts a staggering 11 Earth days. Imagine sunrises that not only herald a new day but unfold slowly, resisting the arrival of midday, and sunsets that stretch out for so long, creating golden hours that photographers dream about. While it sounds idyllic, it also has significant implications for its climate and habitability. How would the biorhythms of humans adjust to the cycles of light and dark on Proxima B? Would we need to eat 3 or 4 times as much in a single day? Would we sleep the same way on this very different world? The fundamental patterns of life as we know it would be at once tantalizingly familiar and strangely disconcerting. It appears as though nature is presenting us with a riddle wrapped in a conundrum, testing our understanding of what makes a planet habitable. You may wonder how we can obtain accurate and reliable data about worlds we have never visited. The JWST deploys all its capabilities like a cosmic Swiss Army knife. More than just a telescope, it is a multifaceted research laboratory in the vacuum of space. Thanks to its innovative technology, astronomers not only look at planets but also investigate them through a prism of analytical tools that would make CSI labs look rudimentary. Using advanced spectrographs, the light emitted and reflected by these remote planets can be analyzed by the Webb telescope. Each element or compound in a planet's atmosphere absorbs or emits light at a specific wavelength. By studying these patterns, scientists can perform a remote biopsy of celestial bodies. Imagine being able to detect the signature of water vapor, carbon dioxide, methane, or even complex organic molecules, all without ever setting foot on the planet itself. This is the level of precision and sophistication that the James Webb Space Telescope brings to humanity's search for life beyond Earth. And Proxima B, with its tantalizing hints of habitability, is one of its prime targets. While earlier observations have hinted at the possibility of an atmosphere and the right temperatures for liquid water, the Webb telescope offers a new chance to confirm these hopes, or to uncover unexpected surprises. Yet, not everything about Proxima B is promising. Its parent star, Proxima Centauri, is a red dwarf, a small but volatile star known for its frequent and intense solar flares. These flares could blast the planet with harmful radiation, potentially stripping away any atmosphere and making the surface hostile to life as we know it. It's a cosmic gamble, on one hand, the perfect distance for liquid water, on the other, the threat of relentless stellar storms. If Proxima B does harbor life, it may have evolved under extreme conditions, developing extraordinary resilience or finding shelter underground or beneath thick oceans. In many ways, Proxima B challenges our assumptions about habitability. It forces scientists to ask deeper questions. Can life thrive under constant radiation? Could alien organisms have adapted biochemical processes completely different from Earth's? Are we, perhaps, too Earth-centric in our ideas of what life looks like? The answers to these questions could profoundly alter not only our scientific understanding but also our philosophical view of our place in the universe. As the James Webb Space Telescope continues its observations, we stand at the edge of a potential new era in astronomy, a time when exoplanets are no longer just dots of light on a distant screen, but real, tangible worlds with landscapes, climates, and perhaps even ecosystems of their own. The search for life on Proxima B is not just a scientific quest. It's a reflection of our deepest curiosity, our longing to know whether we are alone. It speaks to the ancient human instinct to explore, to venture beyond the known, to imagine new possibilities. And maybe, just maybe, it hints at a future when the story of humanity will no longer be confined to a single small planet orbiting a modest yellow star. Maybe, one day, someone, or something, will stand on the shores of Proxima B and look up at a sky where Earth is just a faint, distant star. Maybe that will be the moment when we realize that home is not a place, but a journey, one that stretches across the cosmos. Bodies that determine more than just atmospheric pressure and density, but also the possible existence of compounds essential to life, such as water, organic carbon molecules, and even oxygen, is not only astronomy. Our space forensics don't wait passively for clues to come to us. We actively search for them, analyzing the molecules and atoms that make up these enigmatic worlds. The Webb telescope is not just an eye in the sky but a laboratory with a very narrow focus, analyst and cosmic detective all in one. It allows us to turn our speculations and hypotheses about alien worlds into ways to either prove or disprove them. By expanding our views of the universe, it is revolutionizing our understanding of what else might be out there beyond our blue dot. Just when it seemed like we had unwrapped the most sensational layers of this cosmic onion, the story took an unexpected twist, just like in any science fiction thriller. Researchers, using the James Webb Space Telescope, captured something extraordinary from Proxima B, a signal so unusual that it spread across academic corridors and social networks, labeled as a possible technosignature. It was an electromagnetic emission so complex and anonymously patterned that it could indicate the existence of an advanced civilization. The collective pulse of humanity seemed to stop at the climax of a revelation that promised to change how we see reality. Could the signal be the irrefutable proof that we're not alone in the universe? And just as quickly as it appeared, the signal vanished, without repeating itself, without a trace, leaving behind not only an overwhelming silence but also a maze of unanswered questions and bubbling theories. Was it simply a transient cosmic phenomenon, a fluke of celestial alignment, or something more deliberate, a coded message, or even a manifestation of a haunting cosmic essence? The solitary emission cast a shadow of enigma over Proxima B, igniting fervent debate and speculation. Was it just a passing anomaly, or part of a cosmic narrative far more intricate than we could ever imagine? You think the mystery lingers, but wait. The next step of our cosmic exploration is finished, but no ink has yet been applied, dried, and new chapters are still being written. This time, it is not typical scientists but Harvard researchers who are leading a paradigm shift in our search for extraterrestrial life. They are not content with just scrutinizing the signals and phenomena we have discussed so far. They are upping the game through the James Webb's transformation of the telescope into a sort of nighttime universe vision device. Their objective? To search for artificial light sources in both the dark and illuminated areas of distant worlds. We're talking about staggering repercussions, like the possibility of detecting a terrestrial version of cities glowing in the dark like luminescent pearls. Imagine seeing the bright points of what might be a metropolis, humming with the cadence of an advanced civilization, radiating its luminescence into the vast cosmic ocean. Let me know what you think in the comments box. If you liked the video, keep in mind to subscribe and like. While Proxima B is currently the poster child of exoplanetary excitement, it is just the beginning. Astronomers are identifying hundreds of other candidates within 50 light-years that reside in the habitable zones of their stars. One particularly promising system is TRAPPIST-1, which includes 7 Earth-sized planets, 3 of them in the Goldilocks zone, with atmospheres potentially high in vapor and complex molecules. This system is rapidly becoming a focal point for biosignature and technology-based signature analysis. Imagine if multiple worlds within one system harbor life, each with unique evolutionary paths, atmospheric chemistries, and geological wonders. Could we find not one, but a neighborhood of alien worlds, each singing its own biological song? As more secrets of the universe are discovered, it raises a compelling question. Do we merely observe, or do we eventually join the symphony? Projects like Breakthrough Starshot are already planning to send small interstellar probes to neighboring star systems. In a few decades, we might not only observe Proxima B, we might visit it, albeit robotically. And from there, the conversation changes. Humanity shifts from being cosmic listeners to cosmic participants. Perhaps in the distant future, we won't just be the watchers. Perhaps, one day, we will be the light someone else sees in their telescope, blinking from the dark side of the cosmos. Blinking from the dark side of the cosmos, a small but undeniable signature of our presence, just as we now search the skies for signs of others. The future of cosmic exploration no longer feels like a distant dream, it feels like an inevitable chapter in our story. Every signal captured, every anomaly analyzed, and every glowing world discovered pushes the boundaries of what we believe possible. We are no longer just inhabitants of Earth, we are becoming apprentices of the universe, learning its languages, its rhythms, its hidden messages. And as our instruments become sharper, our reach farther, and our questions deeper, the universe seems to respond, not always with clear answers, but with an invitation to keep looking, to keep wondering. Maybe the greatest revelation won't be a grand, undeniable message carved across the stars. Maybe it will be something quieter, a faint, steady glow from a distant shore, a pattern in the static, a chemical whisper in an alien atmosphere, proof that life, in all its stubborn brilliance, refuses to be confined to one tiny blue dot. In the end, the search for others is also a search for ourselves, for what it means to be alive, to be conscious, to be part of something vast, ancient, and magnificent. The cosmos is waiting. And so we continue, one photon, one signal, one dream at a time.